start streaming. We're live from downtown Mill Bay. We've got this, we've got that. If you make an ion, what distinguishes an ion from something else? The plus or minus. You must have a plus or minus. Put brackets around it if you've done it. Give it plus or minus. Pardon?
What if it's neutral?
That's not going to happen if you're an ion. Unless you pick a noble gas. Excellent. We got oxygen there. Sodium. Looks how does it have so many electrons?
Two electrons in the valence shell. You have to
How many in valence shell?
8 is 2 and 8. Like, see, carbon here has 4 electrons in the valence shell, right?
How many when it's
if you give those 4,
what?
If you give those 4, you end up with just one shell of 2 electrons. Why do you choose to tell you?
Yes. The only problem is that you get one metal and one non-metal. So that means because I was aiming for one positive and one negative. Can you make one of those negative? Is there one of those that can be positive? Pardon? Negative. One of them can. What?
Oh, one of us?
That's titanium. Because titanium is pretty strong metal. I wouldn't expect. Also, yeah. Titanium's in the wrong spot to do that. He needs +4 for a different reason. Oh, I see what you've done. The potassium, however, needs work. The +1 is correct. The valence shell is not.
Oh.
Iron +2. Boron looks good. Yeah, and now the potassium looks good.
Yeah.
Why did you make it minus? Iron 1, 2, 3, 4, 5, 6, 7. One of the things I said the other day, and this will help you a lot, is we don't use metals in the middle transition areas. So pick a different metal. That makes your job so much harder. Okay. And this is your regular one. It's this one that's supposed to be charged. So what are you doing to get from here to here? So this doesn't have charge. But something needs to happen to it down here to get to a charge.
When did they talk about that? When did they talk about that?
And everybody likes using titanium. I did say last day, don't do anything in the middle, but it's close enough over you can kind of get away with it. However, how many valence electrons is titanium? No. TI? 4. There's 4. So your first one doesn't seem to have that. The boron wouldn't be -1. Carbon looks good. And lithium, yeah, lithium looks good.
He did it.
I can't do it. You're sucked, dude.
Boron needs work. The titanium needs work. It needs work though. Carbon, let's go. Oh, carbon looks good. Lithium looks good. Sodium looks good. Oxygen looks good.
You literally did the same with our mess. Now I have used to be able to do now I start with 5
So you go
3 electrons.
went from 3. You just added 1.
That's 3 electrons. Yeah. I can do the 5. That's only. I used to like.
Who's your partner?
I did the red 5 before they changed the
You've done it before.
Yeah, that is.
Question. explain that?
Say, get rid of one.
That's what I did.
Yeah,
Hey,
you
the
have
dice-
to draw the new one, so just take away one of those.
Yeah, they're making a mutt.
Yes.
Yeah.
And then it's a mutt.
Yeah, that's right.
Will is we thought it was
I think
an
it's something right
No,
here.
that's not how you draw that.
No, you just get rid of it.
Excellent.
It's just
Potassium, boron there.
And why's your type?
Potassium is better, the boron is
Oh, that
still.
was the chart.
A wouldn't be +3. You've added way more than 3 electrons.
No, what do you do?
You've added a bunch of electrons.
No, don't you, isn't it the opposite? Because there was 3 in the outer shell.
There was 3, yeah. I didn't-
Just plus means plus one.
Oh, that's a hard one.
I'd rather kill.
Did you add electrons or take them away?
Say, why didn't you get rid of three?
Why do you
What?
Get rid of the three is.
Three's not right.
Why not?
Oh, no, that's not the
The
valence
inner
shell.
shell, like what?
So the valence shell right now has 3 electrons.
Electrons.
I know, like,
So it's easier to take away one.
Yeah.
Normally,
I can
3. You take 3 away.
Maybe you're right, I don't know.
things. Like, if I do this, I can put it at the start, and I
Oh,
can
yeah.
jump there, and I can have to hold the,
Yeah, no, it's good at 0.
and I just can't move my.
No.
Why do you do this?
Yeah, don't do that.
I just like slide off.
Push your partner.
Yeah,
Excellent. So, what would we do here? Add 2 or take away 2, 4, 5, 6?
right. Totally do that.
Hmm? Okay, if it becomes 8, then it becomes -2 because you added 2 electrons. So you have to show that diagram so you didn't have all the dots. Now you added 1 to that. That means it would become -1. But you wouldn't add 1. You'd have to add how many are in the shell? No, how many fill the shell? 8. You'd have to add 7. Is that very likely? No, so what would you do to that 1? Yeah, you can remove it. Yeah, you can remove it, but you've added it. Yeah.
There you are. Look at
If
the
you
bone.
minus it. No, if you minus it, you're not adding an electron, you're taking away an electron. No, because I make covenants too.
I was in the shower.
Because you built the shell, you only have 2. When you're trying to take away 6 or add 2. The choice here is adding 7 or take away 1. Which is easier? Take away 1. Like right now, like take it away.
No, it doesn't do
No, take it away. You just agreed. Take it away. Not that one. The electron.
But, like, I don't like it.
And the other one that you added by mistake. There you go. And so you take away an electron, what's the charge?
It is sad that I'm used
Or, no, it's neutral here. Because it has the same number of protons as electrons. So yeah, it's +1. So it's only +1 once you take away an electron.
I hate Jurassic.
Jurassic Park movie.
Excellent. Okay. Put this on your page somewhere. I added this as an extra. So find a spot where we can do that. Now when I read it that way, I've made a compound. And this is different than this compound. What kind of compound is that one? What kind of compound? Of 2 types.
It's like convolute.
Yeah. Now, I don't think I have everybody quite yet.
Ionic and convolute.
Ionic and covalent. So this one's covalent. Someone else, how do you tell at the back? How do you tell a covalent compound from an ionic compound? Yep.
A covalent compound is a non-metal in the middle.
Yeah.
An ionic compound is 2 metals.
What about? All nonmetals. So we can tell, and this is the type of Lewis dot diagram you do for nonmetals. Lewis diagrams are used mostly for nonmetals, but we can use them for covalence, for ionics like this. So this is ionic, and why did you say this is ionic?
Because it's, oh no, it's two non-metals.
That's two nonmetals,
Oh, it's a metal and a non-metal.
metal and a nonmetal. So we have a metal and a nonmetal. If I can call up your periodic table for a second. Data booklet. Go, gadget machine. So in your periodic table in this one, right there, these are all the nonmetals. It's labeled for you. These are all the metals, so that it is. They don't all have these charges. These are only their charges after they've lost or gained electrons. And they've changed their Lewis dot diagram to cope. So here, draw the Lewis dot diagram of the atom, and then draw the Lewis dot diagram of the ion. No, you have to find a spot to do this in. I added this afterwards because I realized I didn't have any ionic examples. Also, in the last little bit of class, I'll be giving out a worksheet, and then I have to run away for a meeting in about the last 15 minutes. I'll still be in the building and hopefully come back fairly quickly, but about 9:15, you will have some time to work. So how many valence electrons in sodium? Zoe?
How many valence electrons in sodium?
Yeah, one. So where do you want to put it? Top. Excellent. There we go. How many valence electrons in chlorine? Hugo? 7. 1, 2, 3, 4, 5, 6, 7. And then given what we just did on the board, what do we do with that single electron on sodium? Zachary? We get rid of it. So at this point, now a lot of people then went, oh, if we get rid of it, we have 8 electrons underneath. No, those are not valence electrons. They will never do anything. They do not get touched. So you don't put them around. It just has an empty shell. That's reasonably stable. That's as stable for some elements as having a full shell. So empty or full. You want to be one of the two. So all we do here is then we just put a bracket around it, because if we lose one electron, what charge is it?
0. Oh no, it's plus 1.
Plus 1. This is a charge of plus 0. Or minus 0. Or whatever you think 0 is. Is 0 an odd or an even number? Why is it odd? It just is because I said so. For chlorine, Ariel, what would it do?
Would you add the ion?
Yeah, add a what?
Charge.
We would add a charge, but how do we get at that charge?
Because you took away one sodium.
I haven't taken away anything yet. Should I take away one or add one?
Oh, add an electron.
Add an electron. Nice whispering there. Excellent. So now it has a full shell. So empty shell, full shell, stable.
Because he minus 1.
Yeah. Because here is where this diagram comes in helpful.
He gave it a negative.
What happens is this electron can go doo, 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 Doo-doo-doo. And go right there.
He added the negative charge.
No, I don't need that.
So it will just get its electron from anywhere around it. If it's with sodium and they're forming a compound, then of course it's going to get it from sodium. Because sodium wants to give it away. This whole thing, we use square brackets around the whole thing when we want to say this thing has minus 1 charge.
Are you going to ask someone what charge?
Hand if you have a question. Yep. And this is how we show an ionic compound. So in a covalent compound, these are actually bonding. And one part we didn't label last day, how many electrons are in each one of these bonds? 2. So 2 electrons per bond. So when we're counting electrons, that's what we do. Now we can go back here. Oh no, I'm going to show you the other method. This method. So this was if we were drawing their Lewis dot diagrams, we join them up. And that works reasonably well for most things. The other method is you count all of their valence electrons. So I've got 2 hydrogens, I've got 1 oxygen, and so that means I've got 1 electron in each hydrogen, I got 2 electrons, I've got 1 I'm going to put OX for oxygen, otherwise it looks like the number 10 instead of 1 oxygen. And oxygen has 6 electrons, and so I have a total of 8. I then decide what the central atom is. Of these atoms, which one is the one that's going to be right in the center? But you have to wait till I call on you. Put up your hand. Zachary! Oxygen. It's the one that you have in fewest amount. So you go oxygen. Let me do that in different color so it's more visible. And then you join it to the other atoms. How many electrons got taken up in that bond? Someone else? Yep. 4. Because there's 2 per bond. And so I start keeping account. How many, at that point you put any electrons on the outer atoms you need to, which would be out here with hydrogen. How many extra electrons does hydrogen need if it already has 2? It would need 6 more if it was anybody but hydrogen. How many is hydrogen happy with? How many electrons fit in the first shell? 2. Hydrogen's in the first shell, only needs 2. And it's got 2 in the bond, so hydrogen's happy. If we were to look at this from the perspective, the reason why it's happy is that hydrogen thinks it has 2. The other hydrogen thinks it has 2. And so they don't need any more. So we don't need to put any electrons on hydrogen. We have 4 electrons left, though. When you're done and the outer ones are happy and you filled them all up, you just take the extra ones and put them on the center one in pairs. This is like the accounting way to do Lewis dot diagrams. Next year, this is good if you don't have any exceptions. Next year in Chemistry 11, if you decide to take it, you'll get a ton of exceptions. So this method becomes far superior. You can really use either one. Sometimes this method is far better because it actually shows you the structures easier. And sometimes this method is way better because you are more likely to get the right answer because you have some sort of exception involved. Using any method you want, do CH4. And where is it? There we go.
What? Yeah, we already did it. Wrote it down.
Oh, you did it, but we didn't write it down?
No, we wrote it
Yeah,
down.
you wrote that on our papers. You just told us through at the end of last class. You told us to do it before you left.
Oh, excellent. I'll do the answer then. But turn to this page and do HCl and F2. Oh, hold it. Attendance. We now have everybody here, don't we? not do them on the board, find a new partner, erase what's already there, and go do those two. New people. Find your people. Find your people. Erase what you currently are.
Whiteboard?
Yep. No, whiteboard. We don't have blackboards.
No whiteboard.
Only. Oh, did you? In the old building, they had blackboard. Don't use your hands to wipe anything off. Please get something. Your oils will actually make it so you can't draw on the board very well. It wrecks the board. So please use a cloth to wipe things off. Excellent. There's another more erasers up at the front if you need them. There's one right. Are you looking for another one? Sure. But what was wrong with that one?
I thought you said not to use it.
Oh no, you can use it. I just told people there was more.
Yo, I take one over. Side. Here, that's all we need. We're 2 versus 1.
He has and then wait.
I think you only need the. Mine is 2, right? One, two, three, four, 5, 6, 7. Yeah, you're right. Exactly that worked.
When you have one of your diagrams, let me know so I can take a look.
Okay, it's this bond is 2 electrons. So if you see here,
Where's your partner?
no, particle here, fluorine, right? Fluorine is like in the 7
Which row? Excellent.
7 bonds.
Explain it.
So if this is 2,
Excellent. Do the next couple of those.
well, I don't know.
Hey, see how it looks good? Who drew it?
No, it's this is 2, 7 minus 2, you get 5, so if you're using the same element, 5 is 1.
Okay, explain.
What? Let's see. That doesn't look like an
And yours, there's something, that looks good. Maybe something different from what yours was there. You have way too many. Something different than what yours. All right. There's that one. I don't think so. Compare with a different group.
We have the same as that.
Yeah, they also need to compare with a different group.
Exactly.
That side's doing. That side. Oh yeah, this whole side.
Did we do wrong? Were we wrong?
That's, no, I think we're not. No. No, you're not.
Go back to the kitchen.
Ah, you fixed the bottom one there, so that looks good. Where's your F? You need your F2.
You're not even in our group.
Yeah, you're right.
Go away.
Zane, why do you say go away? They're supposed to come to us.
They are?
Yeah. You're allowed to ask other groups for help.
But what if they ask
I feel like they need to mention this given that a group was trying to shove them away.
We'll find out about this. No. I don't want to.
Pardon?
This one here, our cable. What's up?
Like one of those? I'm shooting them more, right?
Why's your line in the sauce? What did you do?
And you're like yeah.
There you go.
Yeah.
I never actually.
Okay, we fix. Fix.
Stop
Fix.
with the dots. You do.
Half fix.
Okay, this is too
The ACL's fixed.
Oh, yeah.
Flooring's fixed. Oh, yours is very good. There's something wrong with your flooring. Take out the line that you drew. Because what it looks like is you just drew that line. But it contains 2 electrons.
Okay, we're the right.
Which electrons are you joining together to make it?
Floor maybe one day.
I'm in Spanish. Make my count. Uno, dos, tres, cuatro, cinco, seis, siete, ocho, nueve,
So you leave them out. Now you
diez. Was that fire? Okay, no, wait, no, this is what I learned. Dame esa la leche. Yeah, where's the milk?
Use those two.
Okay. I've never spoken.
You got rid of
Quiero una hamburguesa.
No, pero flores también, porque tienen dos tipos.
Okay. Try the next 2. Or hold it. You guys have already did it so well. I'll switch up the groups and that way you'll be able to help someone. The next 2 with these people. New groups.
And that's for which one?
The next 2.
Oh, we got new.
So, the next 2 are...
7, 8.
William,
No, they're not. They're NH4 plus and CO2.
I already did those 2.
No,
yeah,
those aren't them.
Those just started existing.
Those are random drawings.
Oh, okay.
Pardon? Naomi! There we go.
Okay, you know what to do.
Kinda.
You please use a cloth to erase, not your hand. Nope. One reason I thought we do it because they're not correct. Start from first principles.
And then what's hydrogen?
it's 5.
That's 1.
There's
1, 2, 3, 4, 5. What does it mean if you got it, man. You got it. What do you do? What do you do when it's
Plus 1.
Oh!
Wait, no, I think you just put 1 on.
I'm doing the old ones on the board so we have a record.
Oh, I got it.
Oh, yeah. 2, so 2, 4, 6, 8. That's 21.
Oh, shoot. You actually have 5 electrons, but you get rid of 1. 4 posts.
You just
No.
Einstein.
It's only Einstein. It's for a compound.
Yeah.
Is this right?
Yeah. Mr.
The NH4? It's looking pretty good.
Plus 1 is for the compound or not?
Pardon?
The plus 1 is for the compound or just for...
CO2.
No, there's a plus one above the NH4.
Oh yeah, you can put it in brackets and put +1 if you've done it correctly. The only thing I don't know, do you have a dot anywhere around it somewhere?
We have the dot above the N, but with the plus
Oh.
one, there was like 2 dots. No, no dot.
What does +1 mean?
Oh, CO2, plastic.
But what has to have happened to get +1?
Protons and
Throw
Right.
out an electron.
So throw away 1 electron.
And then O2. What's 2?
Yeah. And then put it in brackets and put plus one.
Or I think we just put the whole thing in brackets.
So for the next one.
Like, that's what we have. Okay, this is plus one.
Bro, why you got the flat one? You have to have the
How many electrons is it?
Carbon has one. Yeah, 4. They got 1, 4.
And drop your
How many is it? 1? 8, so you're not done. You can't add electrons.
5.
If you take away or add electrons, you get a charge. Does it have a charge?
I don't know. This you got that.
Esto no sería.
I would suspect. Erase this. Look
Oh, I
at this
thought
part.
you said it's
Yeah, this here, it has its balance right now. Can I add this?
Yeah. Erase that. Individual one. Look at that. It's hard. Saying device.
Wait, don't. I think you have to check them before you erase
I
them.
know, but it's too
If you are stuck on the carbon dioxide one, which as far as I can tell, everybody is, draw the individual Lewis dot diagrams for carbon and both oxygens, and just like, look at it really hard. Nope.
Yeah, I need my glasses. This L. But he did it like this.
That's good. The NH4 is good.
Yeah.
Most people got the NH4. That's looking really good.
Oh, man.
Where?
The oxygen.
The NH4? Nope.
I told you that.
Nope.
I would like to
Gave it a charge. Does it have a charge?
I didn't know.
Okay, everyone knows how to say that.
Go back to go back to this. Yeah. Look at it for a while. Ooh, you're on the right track. Now just draw that with straight lines. Beautiful. Beautiful. Things of the lab.
Yeah.
So this one's still missing.
Okay, how we
No,
can do
like,
this?
you have to do like, okay, oxygen has 6. 1, 2, 3, 4, 5, 6. And the other one has 1.
A group just got really close. I'm waiting to see if they get it.
This one has like 1 is 2. Yeah, we added this name.
Nope.
8.
Draw them individually. See what you get.
Oh, wait, what?
Oh, you draw them individually. Yeah. Now stare at them.
Okay.
Okay, is this good, Mr.?
Yeah, that makes more sense.
You need like 2 electrons here and here.
That one's closer.
Yeah.
Yes.
Yeah.
That's right.
Yeah.
It's good?
Okay.
I think it's
Yep. Except you don't have to draw them angled. They can just be straight lines.
Oh, no, we're not, because he's going to.
That makes them look tiny. But yes, you got it.
Yeah.
Oh, and
2 groups have got it. No. No. Too few electrons.
no, I had these 2 here, but that was wrong.
Yeah.
So what's the right?
Oh, you draw them individually. Stare at them.
Do I have to rewrite it?
You can take a look at the groups who did get it, and they've left some of their working on.
Like we get rid of the one on top, one on bottom, just do like that, is that better?
Now, why does your carbon have like 2 pairs? That's not
Carbon has 4 layers. Like this?
Yeah, so redraw that with straight
So
lines.
like a line, put 2 here, and then yeah, like the bigger ones, like that, yeah.
Wait.
And then get
Let
rid
me
of
go.
the,
No, straight lines.
I don't
Where
know
are
what
they
it is.
bonded to? The oxygen to the...
Wait, Mr. Nichols,
Okay, Okay, draw it like this.
I think it's
Oh,
no. Like
so close. For some reason, you included extra electrons.
Oh!
Like how many lone pairs?
Yeah, that's probably correct.
This is
This part?
Yes.
Yeah, you have started off well, and then but I think it's because your electrons are paired on your carbon, and I don't know why you've sort of gone off. That's looking awesome. So close.
Is this correct?
Too many electrons. Good, but they're not paired up. But other than that, good. Electrons are correct, not paired up.
Yeah, we have to take.
That is weird. That's so weird, but it works.
Oh, it has to be
Yeah.
paired up. What is
Drawn
it?
weird, but yes. Oh, that's beautiful. What's oh, okay, yeah, then it's perfect. Yeah, as long as that's the right.
And this can work too, right?
Yep, that's perfect as well. Yeah. Yeah, yeah, excellent. Okay, have a seat.
How was your group?
Good.
How long did it take you to
Chocolate like this.
Here, I will not take that. I will not take that.
Okay, I'm going to show you how to do both methods for the first one. One of the reasons the accounting method can sometimes work, especially when you deal with charges. I got nitrogen gives me 5 valence electrons, 4 hydrogens, 1 each gives me 4. But if you have a +1 charge, what has happened? What has happened to your electrons? You lost one. So you count that and you go, oh, I only have 8 electrons. Nitrogen is the central atom. I put it around. And hydrogen each has 2, which we've just determined is fine. And nitrogen has how many? How many electrons does nitrogen think it has?
5.
Not 5. Right here in this diagram, how many?
4.
Nope.
6.
How many is in each bond?
2. 1.
2.
12, 14, 32. How many in a bond?
2.
2. So nitrogen thinks it has 8. So those of you yelling 8, you were correct. This is known as the octet rule. So add that in. Most, not hydrogen, atoms want 8 electrons. Whoops. In their shell, in their valence shell, get it together, Mr. Neufeld, for bonding. And I say most because everything we do is going to, except for hydrogen, has the octet rule. But there's like 80,000 exceptions. And so immediately your teacher next year will say that they lied. Yes?
Can you explain the like, that side again? Because I just...
Right. How many valence electrons does nitrogen
No,
have?
I just want to explain... I don't understand the +1.
What charge is this?
Oh, okay.
+1. So I put the charge there. And then that is the number of electrons. If you have a +1 charge, it means you removed an electron. So I can deal with the charges there. And that's really helpful for me when I have covalent compounds that have a charge.
All right.
We'll see those later when we do naming. They're called polyatomic ions. And we'll introduce them in a bit. Now, if I was doing this the other method, I would go nitrogen, 1, 2, 3, 4, 5, which is probably what you did. Hydrogen with 1, hydrogen with 1, hydrogen with 1. And then I would start grouping them. And I go, okay, that could bond to that one. Oh, wait, I need 4 hydrogens. Hydrogen with 1. So I can bond that one, this one, this one. But I can only bond 1 electron, and this one's gone. But I realized, oh, I've got a +1 charge. So at that point, you just have to realize, oh, I need 1 less electron. And this will make it work. It's not as elegant as the other way. It doesn't have the same accounting. But as long as you remember to remove an electron, you'll get there eventually. And that's how you get to here. Again, if you want to show it as a charge, square brackets around it, +1. Oh, no, down here. Very impressed with the number of people who got here in the end. Well done. This one stumps more senior students regularly. And the reason I kept saying go back and just stare at the Lewis dot diagrams is because if you stare, you can see them. It's the lone electrons that like to pair. So you can pair these up and pair those up. And every time you do that, that is a single bond. So you create a compound with a double bond. Now, some of you drew it like this, which is fine for a Lewis dot diagram, but this would immediately snap like this because electrons are negative and they don't like each other. So they're trying to get as far from each other as possible. We compare that to water, which I think we did very early on. Water actually looks from the side a lot like this. These are negative and push it up. That's why water is drawn like it has Mickey Mouse ears. They're bent away. This gives water different properties. Because it has that bent away, there's an attraction to itself. It can become liquid at room temperature. It has an asymmetry to it that allows it to do some pretty interesting things. Whereas carbon dioxide, 2 oxygens bonded to a central atom, two hydrogens bonded to a central, very similar structures in many ways. If I could learn how to draw for like 2 seconds. Hydrogen to oxygen. So we have an oxygen compound. This one's bent, but we still have like 2 things connected to one thing, 2 things connected to one thing. But this one's straight. This one's bent. Because it's bent, it can do way more interesting things. Because it's straight and very symmetrical, doesn't even bond to itself that well. If you take a mirror, it's the same all the way around. It's a gas at room temperature. Doesn't really do very much. And that's why water's a liquid and carbon dioxide is a gas. Now we have a new one, N2. Ooh, NO3 minus 1. That'll tell the extending highs. New groups. Erase what you currently have. Please don't use your hands. This will be the last one.
Which one?
And I'm going to stop you after 5 minutes. In fact, just N2. Just the N2.
You got a marker?
Just this one. Oh. Who are you with? Zoe.
Can you do bonds like this on top? This? Does this work?
William. There's 2 Williams in the class. Sorry, yes.
Is this right?
Nope. You're close. Well, you're doing things that I want to encourage you for. You're actually not very close. But you're doing things. You're doing things. Yeah. You have 3 minutes. 3 minutes to get as close as you can. Only N2.
Wait, Ariel. Can you pass me the eraser?
Just draw it over.
Pass me the eraser.
Oh, we've got some clever people around here. Your Lewis dot diagram is incorrect. You have the wrong number.
Am I right here?
What do you?
You go around, no, either right now or electrons, you don't have them all over. So this should be all over. No. Stop. Because I'm going to give you a worksheet next. Good. That was good. That was good. Beautiful.
Yeah, where's the milk? Why are you asking where's the milk?
They're right here.
Oh, there we go. Okay.
You know what? I'm gonna do the last one.
How many
because I-
electrons are in the bond?
That's a
That mentions these technically. So this is the function. You want the octet rule. 8 electrons. Okay, have a seat. Have a seat. Beautiful. Beautiful. Dun, dun, dun. Once you're seated, I'll give you your worksheet. Yeah, that's beautiful.
I mean, I can, you know, like, be getting.
Who does not have a worksheet? There you go. You don't have a worksheet. You don't have a worksheet. What? Are you saying wild emotions? Invention.
The greatest invention of the 21st century.
So I think I figured out how to do this one. This here is the extra one, that's the minus one, and then these two actually end up going together.
No. It's so creative though, I admire it. It doesn't make a ring.
Well, yeah.
They're very close,
But
but it doesn't make a ring.
okay, just not this one.
So here, worksheet. Are you, where are you working? There you go.
This is where I'm at. So,
Anybody else need one?
this is where I'm at so far.
Do you have one? Yes, you do. Who said they don't have one? Who does?
I just have these. So this is sort of this is right. So I draw this down.
Okay. If I could just get your attention. First page is a review. We did work on ions and adjusting the amount of electrons. So for the purpose of this worksheet, I've given you a bunch of elements. You get the number of protons or atomic number, so that's very similar. But then you have to pick a charge. So you just go to this periodic table, find them, and you have to pick a charge. There may be more than one charge there, but if you pick a charge, that's the charge you're going to stick with. I did it with cobalt to show you, and you could pick +2. Now somebody else in the class might have picked +3. Both would be correct provided all your other answers match. So if you pick +2, then it's cobalt +2, so you give me the symbol of the charge. The number of protons is 27, same as the atomic number. And then the electrons, if it's +2, is 2 less than that, 25. If you pick +3, then it's cobalt +3, and the number of electrons will be 24. Do those. And then, on the next page, practice Lewis dot diagrams of the individual atoms, Lewis dot diagrams of the ions, and then some structures. Question, yes.
This is gonna be homework.
Pardon?
This is gonna be homework.
Yes, this will be homework. Good.
And like, do we have to say like +2 or +3? Or just
No, you just have to pick one.
Okay.
I just wanted to show that you could have picked something else.
Oh,
Oh, tomorrow's quiz?
yes. No, after tomorrow. Like Saturday.
Oh, Saturday's quiz. A very good question was asked.
Yeah.
Are Lewis dot diagrams on the quiz?
Yes.
And Some are. Lewis dot diagrams of atoms and ions, and maybe one simple compound. But also, your ability to use Bohr diagrams and Lewis diagrams and show charges. So ions, number of protons and electrons. So this will be useful studying for you. Yes, sir.
Has there first quiz been marked?
No, not quite yet. You'll get that back though. People keep doing it.
Okay, but we have to choose like the same answer. So.
Okay.